Following on from our previous video, we were trying to analyze our f prime here, and we deduced that as x tends to infinity, f prime will head towards zero, and then also when x heads towards negative infinity, f prime will head towards zero, meaning it's going to be flat around here. But then, you can look at f prime here. Look at f prime. You see, f prime breaks down when this thing here equals zero. F prime breaks down when this thing here equals zero. So something weird happens when this thing here equals zero. And also, what does it mean to have f prime? What does it mean to say that f prime breaks down? So let's try and investigate what happens when this thing here equals zero. Okay, so hang on. So we are trying to investigate what. So let's investigate what happens when f prime breaks down. Because looking at f prime here, we know that it breaks down when this thing here is zero. So let's try and investigate what happens when this thing here breaks down. Okay, when this thing here breaks down. So this thing here breaks down when this thing here is zero. So let's just try and concentrate on this thing here being zero. Okay, so now when you're here, divide both sides by 5. So that would then take you to here. Okay, and then when you're here, power both sides by this, and then power this side by this. Remember, x to the whatever. These two will get multiplied together here. So that will then give you this. So 20 over 20. It's like 1 here. Anything to the power of 1 is this thing here. Okay, so now x equals this thing here. So remember, f prime breaks down when x equals this. Okay, right there. So f prime breaks down when x equals this. So what that means is f prime breaks down when x is along here somewhere. So something weird happens. Well, f prime breaks down, but we still don't know what it means when f prime breaks down. So for the time being, something weird happens around here to the gradient. Something weird happens to the gradient. Now let's look at this. Hang on. So if we try and put this into f prime, we will get something like this. Okay. So we will have a definite number over. Remember, when you try and put this into here, then this whole thing here will be zero. So in effect, when you do this, put this thing into here, put this thing into here, this thing here will equals this, and then at the bottom we know that it's going to be zero. So you will have a definite number over zero. Remember our section on limits. Okay, our section on limits is that when you have a definite number and then x tends to zero, then you will have something like this, where the limit does not exist. And then if you look at if you can remember this thing here, the limit of 1 over x squared. So 1 over x squared looks something like this. You see our situation here, looking at f prime. You see we've got two situations here. We've got this thing and this thing here. Now this thing really reflects our situation here. You see, if you look at f prime here, you see we've got 1 over x looking something like this here, and then we've got something like this with 1 over x squared. You see, this thing here is always positive. That's why it's like this. This thing here can be negative. That's why it's like this. If you look at this here, this thing here actually is always positive, and you have to really stare at this to really understand why it's always positive. Okay, imagine this as being this 5 bubble here, and then rewrite this as to the power of 4, and then this. Okay, because if you multiply these two together, it will give you this. So you can see here, this thing here, because it's a power of 4, it will always be positive. This thing here will always be positive. Therefore, well, imagine this as this, then it will be positive. So the point that I'm trying to make is that something weird happens at at this. Something weird happens at x equals this. Okay, but then what we have here is that the gradient at the derivative. Okay, we are not talking about the function itself. The derivative looks like this. Hang on. The derivative looks like this. It will head towards infinity, and then it will do something like this. Well, no, sorry, it won't go over here. But the point here is that hang on, bear with me. So what we have is something like this here. It's going to go up like this, and it's going to go up like this. So the from the left hand side of this, the gradient will be very, very steep. That's this being very high. And then from the right hand side, it's also very, very steep, but and also positive. So what you have here is this scenario here. What you have is this. If you look at it now, look, the gradient's really, really steep now. Okay, and then it's still really, really steep, and then it flattens out. So what you have is something like this. What you have is a graph looking something like this. It's like vertical right here. That's what you. That's what if you have if your derivative looks something like this. Hang on. If your derivative looks something like this, it means that you're going to have. Hang on. It means that blah blah blah, and then you hang on, blah blah blah, and then you're going to have something like this. Hang on. You're going to have. Hang on. Bear with me. You're going to have something like this. You're going to have something like this. You see, right at this point here, the derivative here is really, really steep, and then when you pass that critical point here, the derivative here is also very, very steep, and then it flattens out. Look at this. Looking at this, it's very, very steep, and then when you pass the critical point, it's still steep, and then it flattens out. So your function in a way is something like this. Because looking at this here, it's really, really steep, and then when it passes past the critical point, it's still very, very steep, and then it flattens out, and then it flattens out. See? So when you have something like this, so we can actually say that our function would do something like this, something like this. Hang on, you're going to have something vertical here, horizontal here. Okay, so this is our next guess here. And then it flattens out. Okay. The point here is that this here would be vertical here, because here, well, I hope you understand it. It must be vertical here. Okay. So this is our next guess here, being vertical. Okay.